All right, so to wrap up our discussion of radical functions and radical equations and radical expressions and all things involving the radical and various roots, we're going to talk about how to graph the square root function. Now, this is something we're going to get into a lot more in depth in pre-calc. So today we're just going to review some function families and the translation rules so that if you see a problem that involves graphing a square root function, you can at least think of it in terms of its parent function and where it's been shifted to. So let's review the function families. So far, we've learned we're going to learn five function families. Today, we're going to add family 4 and 5. And by the time we get to the end of the school year, we will probably have a total of 9 function families. We're going to add 2 more function families in Chapter 7. So the first of our function families is the linear family. The linear family is based on the function y equals x. And the linear function family, the parent function looks like this, where it crosses through the origin, and it has a slope of 1 over 1. The second function family that we've worked with this year, and all through our algebra career, is the quadratic family. And the quadratic family is based on the parent function y equals x squared. We know that the quadratic function family all look like parabolas, U-shaped graphs. And so this is a U-shaped graph that crosses through the origin. The third of our function families is the absolute value function families, and these are really in no particular order. But let's talk about absolute value. Absolute value graphs are all based on the function y equals the absolute value of x. And these graphs, you probably remember me saying that they are V-shaped. Absolute value has a V, and the graph makes a V. So absolute value functions are all going to resemble that absolute value function. And then today, let's talk about the square root family. We did touch on this for a quick minute in Algebra 1. The square root family, all of these functions resemble y equals the square root of x. And they look like, starting at the origin, kind of heading off something like this. So if I wanted to make a graph of that, remember that I can't plug in anything less than 0. 0 is the smallest number that I can plug into that function because I can't plug in anything negative. You know, you can't take the square root of a negative number. The output would be 0. Another nice friendly number to plug into that function would be 1. I would plug in 4 next, and that would give me 2. The square root of 4 is 2. Another friendly number to plug in would be 9, because the square root of 9 is 3. So here's 0, 0, here's 1, 1, and then here is 4, 2, and then I can go all the way over here to 9. I don't know if you have that much space. We can continue this on, and we'll say that this is 9, 3. Well, not drawn to scale, but close enough. So the square root function, the domain of the square root function is going to be positive values. So for this one, I would say that the domain is the interval from 0 to infinity. The range is also from 0 to infinity, because you're not going to get out a negative number when you're square rooting something that's positive. The last of the function families that I want to add to this list is the cube family, the cubic family. So maybe I'll scoot this up a little bit. Let's talk about the cubic function. So all of these functions are based on y equals x cubed. These functions do something like this. And I'm getting this information from a table of values. Let's take a look at this quick table of values. I'm going to plug in the integers from -2 to +2. And then if I plug in -2, -2 to the third power is going to be -8. -1 cubed would be -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. So I'm crossing through here at the origin. I'm crossing at 1, 1. Let me redraw that and start over here. Over 1, up 1 is right here. And then I'm going to say that this is over 2. We'll call this 8. Then come back -1, down 1, come back -2. This was +2. And then we'll go down. We'll say that this is -8 right about there. And that's the cubic function. So the cool thing about the cubic function is the domain is from -infinity to +infinity. And the range is also from -infinity to +infinity. Now, I hope you're listening to this video. I hope you're listening to me say this. You can cube anything. And if you can cube anything, you can get out something positive or negative. So all real numbers are the domain and the range of anything cubic. All right, that's all I have to say about those 5 function families. Like I said, we'll take a look at the radical families, so like maybe a 3rd root or a 4th root in pre-calc. There's kind of a lot more to think about with the root families. Before we go, let's review the translation rules. So I'm sure that you have these in your notes somewhere else, but I want to put them here again, the translation rules. We can't talk about the translation rules enough, because if you've got a general idea of how the translation rules work, you're going to be set for the rest of your math career. Translation rules, no matter what our parent function is, if we take that parent function and we add a constant outside of the argument, then this is going to shift our whole picture up. If you take your function and you subtract a constant, that's going to take the whole picture and just slide it down. Now, inside the parentheses, if you add a constant, this is counterintuitive. It's going to move it to the left. If you subtract, it's going to move it to the right. A few more translations. If you take the opposite or negative f of x, this is going to be a reflection over the x-axis. If you take your function and you put the negative inside the argument, so maybe underneath the square root or inside the cubing part or inside the absolute values bars, this is going to be reflecting it over the y-axis. And then the last thing I want to talk about is if you multiply a constant c times a function, that's going to be a vertical stretch. A vertical stretch. Now we could put the constant inside the argument, so like, you know, we could do, I don't know, this, we could say y equals 4 times the square root of x or something, and that's going to be a, that's going to give you a horizontal. This will actually be a compression, but we're going to worry about that again in pre-calc. So come back next year and we'll take another look at these stretches and compressions from a vertical perspective and a horizontal perspective. All right, we're doing good on time. Stay with me for a couple more minutes. Let's take a look at some examples. In example A, I want us to graph. We're going to graph y equals the square root of x plus 3 minus 2. So look up above, look at your function families. What is this going to resemble? And then look at your translation rules. What rules apply? I'm going to be shifting this parent function to the left 3 and down 2. So here's a quick rough sketchy sketch. Come to the left 3, go down 2. This is the root of your square root function. And then from here, just kind of go like that. It's not super accurate, but you know what? We're not launching a satellite into outer space. We're not building a bridge here. We're just making a rough sketch. I'm happy with this graph. I see the 2 translation rules that apply, and I see the general picture of the parent. It resembles its parent function, just like you probably resemble your parent. Good enough. Call it a day on that one. And then the last example I want to do together, let's take a look at graphing y equals x cubed plus 5. X cubed plus 5. Okay, so what do I know? I know that this just means that I'd be shifting this up 5. Nothing is happening left or right, and there's no reflection or stretch or anything. I take a look up above and I look at the parent function really quick. And then from here, I'm just going to go up 1, 2, 3, 4, 5. And then this is a good sketchy sketch of the cubic function shifted up 5. Good enough. Like I said, rockets are not being sent into orbit, so it's all good, just a rough sketch. All right, we did it under 10 minutes. Great job. Finish this up. See you tomorrow.